I would now like to call upon Fahima Taranum ma'am and Sumaira Sultana ma'am to speak about AI/ML techniques and applications. They will provide their insights on paper number 38 titled Impact of Meteorological Conditions on Air Quality Prediction Using Deep Learning.
Based on meteorological conditions. Here we have used a.csv file and we have worked on 8 columns which includes PM 2.5, PM10, NO2, CO, O3, air pressure and temperature in order to detect what would be the impact of air quality in order to deal with the cases like respiratory problem or any other lung associated problem. As she has implemented the project, I would invite her to go into the technical aspects and tell us about the details with respect to the proposal which she has implemented. See, these days the technology is emerging, so we have many options of implementing our proposals by means of many deep learning, machine learning or AML techniques. But the challenge here is to recognize what would be the best appropriate data set which we can use, and out of the approaches which are available, which approach we should apply in order to estimate the best results. So we have used some performance metrics here like accuracy and precision and recall in order to recognize our prediction level. On an epoch of the multiples of 25 times we took in order to calculate our accuracy. So I would hand over the session to Sumaira Sultana to just talk about the technical aspects which we have used in this proposal. Thank you.
Good afternoon everyone. My name is Sumaira Sultana and I'll continue with the technical aspects of the project. So our project is titled as Impact of Meteorological Conditions on Air Quality Prediction Using Deep Learning. So the whole idea of the project is to find out how the meteorological conditions like temperature and pressure are affecting in prediction of the air quality. So the outline for the presentation is as follows. So since meteorological conditions play a crucial role in predicting the quality of air, but they are not very much the deep learning models that are giving us the accurate results of this. So in order to achieve this or to find out how they are affecting the prediction, we are using artificial neural networks, which is a black box technique. So firstly what we are doing is we are collecting the data set, the air pollution data set, which will include the attributes such as PM 2.5, PM10, sulfur dioxide and the meteorological factors like temperature and humidity. Then we are developing an artificial neural network model and we are making predictions under 3 conditions. That is, first we are taking only PM 2.5 data set and then we are trying to see like what accuracy could be achieved out of it. Then we are considering PM 2.5 along with temperature and atmospheric pressure and seeing what accuracy could be achieved by it. And then we are taking all the pollutions like we are taking 8 things from it, and then we are trying to see what would be the accuracy that would be achieved if we are considering all the factors. So as we all know that environmental issues have been brought up by the ongoing acceleration and air quality has been a prime concern. In recently, like a week back, I think Delhi was facing a lot of air quality pollution over there. So it is important for us to predict the air quality beforehand and to see like what factors are influencing in the pollution. So we are taking the data set which will contain the attributes such as PM 2.5, PM10, sulfur dioxide, nitrogen dioxide, carbon monoxide and ozone. These are the attributes that we are considering because World Health Organization has told that these are the major pollutants that are contributing in the quality of the air. So our problem statement is to air quality, and in order to find out that, we are developing a deep learning model using artificial neural networks. So our primary objective is to develop a model that will determine how meteorological conditions are affecting in the quality of the air. Then we are also employing an artificial neural network and predicting the accuracy under the three conditions that I have previously stated. And our objective is also to decrease the error and increase the accuracy, precision, and F1 score. The challenges that were faced during the execution was like there was limited and inconsistent data that was present, complex interactions was there among the attributes that were there, and the overfitting of model and interpretability. So these are few of the literature survey papers that I have referred in order to implement. So I have taken the paper revealing the influence of meteorological conditions on air quality prediction. So basically the main idea for my project was from this paper. In this paper they have used the LSTM and GRU techniques, and they have tried to predict how these are impacting. So similarly there were previous papers that were published in the year 2021 which is titled as Smart City Air Quality Prediction Using Machine Learning. So this paper used NLP and random forest. So in this paper, the random forest achieved the better results. And there was another paper called Air Pollution Prediction Using Machine Learning, which I've also referred. So in that, there were several machine learning models that were being considered, but the performance metric used was only root mean square error. So now, a paper called Machine Learning Model for Air Quality Prediction of Smart Cities was published in the year 2018. So in this paper, neural networks and SVMs were used to predict the air quality. So the gaps in the research were like mainly all of these papers that were used, they were only predicting, they were only considering one attribute, that is PM 2.5, and the limited parameters were used for the prediction. And since meteorological conditions play an important role in predicting the quality of air, that parameters were not considered. So, as I told, the existence technique include the LSTM, in which they are only using three pollutants, that is PM 2.5, PM 10, and sulfur dioxide. And the drawbacks of LSTM would be like it is more complicated than like the robot technique, that is artificial neural network, and it is slow to train on large data sets, and sometimes it is not well suited for prediction of classification problems. So my proposed technique is artificial neural network, where I am considering more attributes other than the attributes those were present in the existing technique. The reason for considering artificial neural network as the algorithm is that it is quicker to train on huge data sets, and it is more reliable. So this is the workflow of the proposed system. So first we are collecting the data set and uploading the data set. The pre-processing of the data is being done, data standardization, removal of mean and unique variance. And in this pre-processing step, we are also generating the air quality index for the data. Then we are splitting the data into the training and testing data. Then now we are initializing the artificial neural network. So I have made two ends. One is the admin end and the one is the user end. In the admin end, as we previously discussed, I am creating three models. That is, one model will give us the accuracy when only one attribute PM 2.5 is being considered, and there is another model that we have constructed, that is PM 2.5 and meteorological conditions. So this model will give us the accuracy when three of the attributes are considered, that is PM 2.5, temperature and pressure. And then we are considering all factors in which we will be using all the 6 pollutants that are being given to us by the World Health Organization, and we will be taking out the accuracies for that. And then finally we are providing the data, generating the result and evaluating it with the help of mean square error, root mean square error and mean absolute error. On the user end, what we have done is using the same data set, now we are trying to predict the air quality index of it. So So the test data that we are taking would be the user input. So this is the general working of ANN, where the input layers will take the data set and the pre-processing, the internal processing would be done in the hidden layers, and finally the output would be generated. So if there are any kind of errors that are taking place, then Atom Optimizer will adjust the weights and bias of the model and until we get the correct results. So this is the algorithm that we are using. Then the data set used for this model is the air pollution and meteorological data set. So as I told that we are considering PM2.5 nitrogen dioxide, PM10 O3 carbon monoxide, sulfur dioxide, temperature and pressure as our attributes, and the size of the data set is 1639 KB. So now let us see what impact all of these pollutants are having on health, and why World Health Organization have told that these are the main pollutants that are contributing in the pollution of the air quality. So PM2.5, the source is that it is emitted from vehicles and industries, and it has direct effect on the heart and lung diseases. PM10 is generated from dust, smoke and other things. So it causes difficulties like running nose and cough. Sulfur dioxide is generated from power stations, vehicles, and it causes coughing and shortness of breath. Ozone is the emission from trucks and industries, and it irritates the lining of your throat. Nitrogen dioxide is again from the cars and burning of coals, and it affects the hearts and lungs. And carbon monoxide is from burning of the fossil fuels, and it causes nausea and tiredness. So these are actually the levels that are being given air quality index level. So for each of the pollutant, if it is lying in a particular level that is being mentioned, then suppose ozone is less than 50, then that means that the air quality index would be good for it will contribute in the category of good air quality index. Let us see how to calculate the air quality index to the same. So first we have to set the criteria for air quality index and identify the pollutants, and these are the ranges that are being given. So for the categories that we are considering are good, satisfactory, moderately polluted, poor, very poor and severe, and the ranges are being given that if it lies between air quality index lies between 0 to 50, then it would be good. If it is between 51 to 100, it would be satisfactory. Mostly few people notice on your mobile phones, mostly the air quality index that lies for Hyderabad usually is in this range of satisfactory, that is, it is always below 100. So these are the ranges, and this is the formula to calculate the air quality index, which is C observation minus C minimum by I into I max minus I minimum by C max minus C minimum. So suppose we are saying that the concentration of PM10 is 250.5, then by substituting in the formula we will be getting the air quality index. So as I told that I have generated air quality index for the data set that was being available in the paper that I have referred as in my data pre-processing step, in order to train the model for it. So this is the generation of that, and let us now go to the result analysis and discussion. So now we are comparing the existing system with the proposed system, and we are seeing that we are taking the metrics as mean square error, root mean square error and mean absolute error, and we are seeing that our proposed technique, that is artificial neural network, is generating less result in all of the three cases, that is with PM2.5, with PM2.5 plus meteorological conditions, and when all the factors are being considered. So these are the formulas to calculate the mean square error, root mean square error and mean absolute error. Mean square error is the actual value minus predicted value the whole square by number of the data points that we are having. root mean square error is the underroot of mean square error, you can say, and mean absolute error is the actual value minus predicted value by number of data points. So now, since I have trained my model on 100 epochs for achieving these results, so my conclusion of why I am considering 100 epochs, I have listed it over here. So when I trained the model at 25 epochs, that is epochs is the iterations that the model will be taking. So when I considered it for 25 epochs, so I was getting 87% accuracy. For 50 epochs, I was achieving 92%, and for 100 epochs, 93.33% accuracy was attained. So now, when we are having the results that are obtained for proposed system, so you can clearly see that when we are considering all the factors, that is all the pollutants along with the temperature, like all the pollutants that are being given by the World Health Organization along with temperature and pressure, that is the meteorological conditions, highest accuracy was being attained, that is 0.98. And when we are considering PM 2.5 and meteorological conditions, that is temperature and pressure, 95% was attained. And when we are considering only PM 2.5, only 89% of accuracy was attained. Maximum of the research that is being done is done only for this area where they have considered only one pollutant. So like this is the implementation of my model that I have done. So first we are uploading the data set, and then we are predicting the air quality under the three conditions, that is with PM 2.5, PM 2.5 and meteorological conditions and with all factors. So when we are predicting it with PM 2.5, the accuracy attained is 89%, and the mean square error, root mean square error and mean absolute error achieved that as follows. A comparison of existing technique and proposed technique is being done, and we can see that errors are reduced with the proposed technique. Similarly, PM 2.5 plus meteorological conditions, accuracy achieved is 95%, and as I previously told you that I have trained the models for 25 epochs, and I've seen that. So like these are the classification reports and everything generated. Finally, on the user interface, it is the air quality index would be generated if the user gives the input. And I would also like to thank all the faculty members and AI, NLP people who have organized it. Thank you so much for giving me the opportunity for the presentation. Thank you so much.
Does anyone have any doubts about the session?
Yeah, good afternoon. It's a great work. Ma'am, can you go to the results slide, please? The epochs you are compared, right? For epochs comparison. Yeah. The next one. Next. Yeah. So you mentioned that here 25, 50 and 75 epochs, we got it's gradually increased. But there is a less decrease of result in 75 epochs as compared to 50 epochs. Then what is the observation from your side?
No, while I've done it for 75 epochs, then I've also tried it for 80, 85 epochs, but I haven't mentioned it over here. So it depends on the data or the batch size that it is taking. Each and every batches will I'm taking batch sizes for each iterations, right? So now it depends on the data that is being there at that particular value. So I think that has been contributing for that.
But the variable, not solution variable.
Oh.
Data will be. Okay.
Thank you.